so I'm down here by this beautiful Triumph 650 parallel inline twin engine, and these have been used in, this design has been used in so much of the British motorcycle industry. These were even used as power generators in World War II aircraft. So what happened is, over the years, as the displacement increased on these, vibration was along for the ride. And by the time you're getting into 650s and 750s, the vibration has become a real issue to have to deal with. So various manufacturers came up with various things. The Norton Commandos have the ISOLASTIC system. I myself had I think it was a 68 BSA Spitfire, an amazing machine. But what I found is that just after half an hour of riding, your hands were basically numb. For me, almost to the point that I couldn't necessarily tell what I was doing with them. Same with your feet in a lot of cases. So, that's sort of, in my experience, the peak of vibration. Some people say the Norton Atlas actually had more. But in this episode, we're going to look at, on our Café Racer build, how can we incorporate some of that isolastic technology into a featherbed frame. And this has been done in various ways over the years, but we're going to be doing it a little bit different. So let's get started.
In the interest of repeatability, I've just tacked on a little tab here that I'm going to use to have this crossbar so I can pull the front down tubes into a position against the neck that's, again, repeatable. So by adding this tab and then a long threaded rod, I'll be able to tighten this, in this case, and pull this. I got one on the other side also, and pull this round tube rearwards or forwards. And if these down tubes need to go this direction, I can shift this back on the back side and push them towards the rear of the jig. But anyway, this is just another attempt to come up with a way to make everything we do very repeatable. So I'll just weld these down on both sides, and then we'll move on to the next thing. Okay, we're just touching up our front bracket here we've made to support and pull in these front down tubes, just to keep these in a good location for welding. Just going to touch up a couple more places here. Okay, we've just added these two sort of outside brackets here to locate the front down tubes tighter up here against the, if I can show it, steering neck. So we can control this width here at the top for welding. So, a similar approach I'm doing back here at the back. So back here at the back where our swing arm mount is, I've just mocked up a basic adjuster nut here, which I'm going to go ahead and tack down, and this will allow us to position this piece in a repeatable way and control the adjustment of this fore and aft. Just a basic bolt that will either pull it forward or use it to push it forward. But once it's locked into place, it will be very repeatable and also removable when we need to remove this piece to free up the frame. Okay, just been working here at this rear area up by the swing arm mount here, and I've got to get a cross piece of 1 1/4 tubing across the rear here in this area. And what I'm finding is that where this piece needs to go is interfering with our rear riser just a little bit. So I've kind of decided I'm going to have to notch this riser a little bit so that this cross tube can get as far back as it needs to be and down. So just a good example of why we sort of tack weld everything together, because as the frame jig starts to take shape, things can bump into each other. And by notching this riser piece and allowing this to go back, I'm hoping to have room to introduce this concept that I kind of alluded to of getting a rear isolastic mount down here. If you're familiar with Norton commandos, there's a Norville, a racing Norton part that is a head steady, an isolastic head steady, and it uses these smaller rubber isolators up at the head steady. Well, on a featherbed type frame, there's not really room to put this head steady up above the cylinder head. So I'm kind of working on the idea of mounting either a 1 or 2 rubber isolastic setup down here at this bottom mount. We'll kind of have to work through this and see how it goes, but the idea is that by mounting 1 or 2 of these rubber isolators down here and tying it into the cross tube that we're just talking about, we can get the isolation here, and then we'll probably have to do the similar setup up here at the top so that the entire engine is set up in conjunction with our isolastic setup here at the front. So I'm going to go ahead and kind of start the process, remove our cross piece riser here, and notch this down so I can get this rear lower frame tube in position to weld it, cope it, and weld it. So that's the plan at this point. All right, we'll use our grinder here to cut these back. Okay, we've got our notches made. Let's take this out of the vise and kind of see what we got here. Hopefully. Still a few pieces. Couple areas to free up still. Okay. So that's made a pretty hefty notch to make room for this cross piece to go as far back as needed. I may actually weld in a couple of pieces of metal here so we don't lose any strength here. So I might just clean this up a little bit, weld in a couple of pieces, and then we'll be able to test our fit. Okay, I've got the rear swing arm riser notched pretty well here so that the pipe can extend through here, the tubing can extend through here as needed. area that we cut back welded back in, just so we don't lose any strength in this part. Might throw a little bit of paint on that. Alright, I've got this sort of basic isolastic mount. I've fitted one rubber here just to give you an idea, and I'm working on the idea of this fitting down here on this bottom motor mount. Let me just stick another isolastic in here if I can. Easier to do with a big bolt. Easier said than done. Not bad. So that gives you an idea of how this little piece would work. I had these brackets, again from A&A Manufacturing, kind of roughed them in, drilled some basic holes, just again to mock this up. So the idea here is that this will go down here, just mounted internally here with some 3/8 inch bolts. Get that in there. There we go. And another one on the back side. Yeah, there. So I've designed this with some adjustability in and out, and you know, we'll get our riser in here in the back, and then using again this idea that there has to be a cross piece mount down here tying in the two sides of the frame tubes. So this piece will go in here, and then we will take a bracket and mount from this edge here to tie into this front edge of the isolastic. So the piece of metal would go right around here and give us this lower isolastic mount. That's the idea here. So we got a little bit more roughing in to do. I want to allow enough clearance in this so that there's plenty of room. I've got a kind of a dummy mock-up transmission case. This one's had a blowout and been welded, so it's not going to be used again. But I've got it as far rearwards as possible, so that kind of sets how sort of the range of setting we have here, somewhere in the middle. We want to have plenty of movement space, but this gives you kind of the idea here where this will all go. I'll have to fabricate some little brackets that go around here to tie in the frame to the isolastic. So that's where we are. Okay, I'm trying to get the distance between these two rear edges of this these inner frame tubes here. You can see I've got a piece of welding wire. Since I can't really get a good measurement in here, I'm using the welding rod to just touch the inner edge here. I can see that I need to trim just a little bit more, so let me do that and then we'll test it again. Trimming about 1/8 of an inch. Test it again. I mean, that's pretty good. Just touching the inner edges of the frame tubes here and then back on the other side. Probably need a tiny bit more. Okay, we'll try it again. Oh. Now that seems really good, and if anything, a tiny bit too small, not much. Certainly don't want it any shorter. Okay, I'm going to use this piece of welding rod and transfer it over to the cross piece I have. I've already coped one side, so we'll transfer this distance over and make the cope. I've got my bottom frame tube here in the vise, and I'm just going to transfer over the measurement. I've already coped this end, just a straight cope, 1 1/4 inch. I'm going to use this piece of welding rod to create this measurement, just slightly over it, and you can see just a little bit long here. So I'm going to pull this up and just nudge it over a little bit. Using these bimetal saws I'm not real fond of, but in this case it works pretty well. Okay, I think that's a good starting measurement. We'll probably have to adjust it a little bit once we get it over to the bike, but this seems like a good starting place. I think we're in good shape, and as always we'll have to put some lube on here to get it going. Alright, let's give it a shot. Yeah, we're through. Actually, I left just a little on the outer edges here, which means it's very close to perfect. I've got the cross piece here that we just cut on the drill press, and I've got it fitted back into our frame jig and our mock-up here, and you can start to see kind of the room we're going to have to work with here on this rear ISOLASTIC mount. Looks like we'll have plenty, actually. Note to self here, to get this cross piece in here, you have to pull this side outer frame tube out a good 2 inches to get this in there, because of the way the copes, you know, go over the top and bottom of the frame. You can see outer frame tubes. You can see that here, top and bottom. And it takes quite a bit of distance to fit this inside here. And then I've bolted it back together, and I can see that it's, if anything, it's just a tiny bit too tight. The way that these outer tubes taper in at the front means that really the cope is not exactly even, and I will have to relieve with the grinder or the sanding wheel. I'll have to relieve this inner edge, you know, a good 1/16 of an inch probably, maybe a little more, so that it's not too tight and we're getting a nice cope front and back. It's kind of split the difference right now. But this, you know, the other part here is you can see why we had to relieve this riser we've been working on so much. But I'm going to be able to use this place here in the riser to make some kind of a little piece of metal maybe attached to it that will in the future locate this cross piece fore and aft here on our jig. So multiple uses. I'll probably mark it and put a little piece that supports this tube in the proper position once we get there. We need to make a few little tweaks. But once we have this in position, we'll be able to address our and sort of mock up, maybe with a piece of paper, the tabs that will go from this piece up here and tie into this lower isolastic mount. But this is a good start. I've tacked up this isolastic rear lower mount, tacked it up a little bit more here with the brackets, and I've also made a spacer between the two isolastic rubbers. These are the smaller rear size, and just to set this up so you can see the two rubbers will just fit on the outer edges of this rear tube. You know, all of this is subject to being revised. We may determine that we only need one centrally mounted isolastic with the spacers on either side of that, but I'm thinking 2 is going to be a good number. So I'll go ahead and mount these internally here so we can continue to mock up this rear area of the frame with these down in here, starting to finalize this rear position on our rear support here. And I'll probably mount these brackets to then support exactly where this tube goes in the future. Okay, I've got this isolastic mount mocked back up into position here, and I've got the two outer brackets here that would be welded onto this rear cross piece. It's a standard frame piece, but just something to, as far as clearances for the future, I've mocked up here is I've got a counter shaft sprocket, a larger size, because typically that's what we run, a larger counter shaft to get the RPMs down in sort of the cruising ranges of a vertical V-twin, of a vertical parallel twin. And I'm just wanting to kind of get an idea where the chain will hit. So I've mocked up again a piece of welding rod just to have a look right back in here as to how much clearance we're going to have on this cross tube, because the cross tube is actually a little bit further rearwards and upwards than it would be in a normal, typical sort of featherbed type frame. That's just basically to make some clearance here on this lower isolastic mount. So in checking this position of the countershaft sprocket going down here to this rear tube, I can see that I've got probably a good 1/2 inch of clearance. This just goes back to an estimated distance where the sprocket would hit, and I've actually kind of been generous here off of the rear swing arm. I don't think we'll really be that far down. We're going to run a smaller rear sprocket if we can get our hands on one. So looking back up here, and again, just trying to kind of see where we're going to be when we finally start to assemble everything. It looks like there will be enough clearance, but not much extra, that's for sure, because you're going to have chain sag, a little bit of whipping, shifting from, going forwards to letting off the throttle, and that can cause the chain to bounce up and down a little bit. But I'm thinking we're probably okay. I have the rear, I have the sort of mocked up gearbox shell here as far back in the slot as it could ever go. This is typically going to be much more forward, but just allowing for the worst possible case. It's as far back as it can go. There's still some clearance here off of it to the housing here for the isolastics, but really, the gearbox shell and this isolastic mount are going to kind of be in lockstep together. The vibration will be coming against these mounting brackets here, which again I've gotten from some that I had from A&A Manufacturing that I've cut in half and sort of coped them to match the 1 1/4 inch diameter of this rear tube. So it's looking like we're probably okay to proceed. The next thing I would do would be to tack weld these two outer brackets here, tack weld them to this cross tube. I've got a couple of pretty thick tapered washers on here, so there's a little bit of play when we actually bolt this down. I've got a piece of 1/2 inch, actually a bolt, but this will be a stud threaded on both ends in the final case. So in other words, I've mocked it up as much as possible, and I think I'm ready to actually tack the brackets on, and then ultimately I'll go ahead and tack these supports onto this riser piece we've been using so much, so that this is a repeatable location for this cross tube. I've gone ahead and done these 2 tacks here and on the other side that will hold these brackets in place. I've also tacked in 2 brackets here that will serve to locate this cross piece fore and aft. The left and right position is determined by the width here, so we don't have to worry about that. This is just to get a fore and aft, and I've got one welded on either side. I can take this bracket off. So that's tentatively holding all that in position. And hopefully you can see this isolastic, you know, it should do a pretty good job of locating this lower area here on the engine mounts, and also providing isolation from the vibrations. So next, let's work on a type of upper isolastic mount that will replace this cross piece here. Starting with a piece of 1 3/4 inch tube here to use on our top upper isolastic mount at the rear of the engine tranny assembly, and I'm just going to kind of face this off so it's nice and square and flat. Cut it with the chop saw, which does a good job, but not as accurate as the lathe. Needs a few thousandths. Pretty close. Okay, and I'll clean up this edge and then do the reverse, and we'll go back to the frame jig. Okay, we pulled this piece out of the lathe. That's roughly 6 1/4 inches wide, and just size to fit an isolastic mount. The old Norton Commando isolastic mounts in here, the same as we did down at the bottom. And here, the idea I've got here is to replace this standard rear sort of Norton featherbed cross piece with one designed to take isolastics. And I've got a couple of brackets, again, from my friends at A&A Manufacturing that they have off the shelf. So with the idea being, we will mount this onto the engine transmission mount, the standard featherbed mount, and tie into this here using these brackets. We'll have to drill this, but anyway, this is sort of the idea I've got, which has been done before, doing the so-called featherlastic mounts, but we're going to do something a little bit different rather than using the shims. We'll get into that soon, but this is the thing. So what I'll do is go ahead and install some of the isolastics. We'll take this piece out and get a cross, large bolt here to just to mock up a little bit better and gauge where these brackets will tie in. So just to get a better picture of what we're trying to do here. Let's take a look. I've got the piece of tubing here mounted in this rear upper isolastic mount area, and I've got the Norton COMMANDO isolastic rubbers, temporarily placed inside the tube with the spacers that they come with originally. And then I've mounted two 3/4 inch spacers on either side here, so that this piece here is rigidly mounted through the rubbers to the main frame tubes here, so that what's floating here, and you can kind of see it wiggling, is the isolastic mount that would then mount onto these orange engine and transmission plates. I've got these two brackets in the right position here, so it's just a matter of drilling these to suit first this hole here, and then I'll want to pick up another hole so that there's no chance of this flexing on a bolt. So we'll put another bolt, which you can kind of see where that would go down here, so that these would be secured to the plates with two bolts on each side, which should be more than enough to then transfer that isolation to the rubbers mounted here, in here. So right now we'll have to find a good position to bolt these on, and then locate those on the tube here in the proper position, so we can get a tack weld to secure these to this tube. So a little bit of fiddling here to get this all to make sense and logical, like we did down here on this bottom one, which is still looking good. But in doing this, this entire assembly is going to be isolastically isolated from the frame, which could be potentially a great thing to have this on a feather bed. So I'm going to go ahead next and drill a couple of pilot holes here in these to look at then securing these to this opening here. That's the stock mount. I'd like to use as much of the stock location as I can, so we don't have to alter these plates very much, the OEM plates. I'm seeing that's pretty close, but that'll be rigidly mounted, so it should be fine. We'll take a look. I'll go ahead and get some basic starting points, and then we will drill these brackets over on the bench press. Just checking this centering here on our rear ISO mount. Pretty close. Over here. Also very close. They're hard to see, but I've put some little spacer tape or shim tape folded on itself here. I've got 3 pieces just to center these brackets around the tube here. It's not a tight fit, a little bit of play, but I'm taking up the play with this shim tape. And I've pulled this over just a little with this bracket to get it even left and right, which I just checked again. And I've also got a stud coming through here, threaded stud, mounting the 2 engine transmission plates here at the same exact width that they are up here at the engine. So that should be in play here for mounting this when we're done. So next I'm going to go ahead and tack these pieces down. Small tacks, hopefully, so I don't melt the isolastic rubbers in here. We would not want to do that, but I'm just going to put a little tack on these. Trying not to put too much heat in this. Let those cool a little bit. In this episode, we've had some good progress on getting our 3 early Norton Commando style isolastics sort of mocked up here and tacked into position. This lower rear, and then now this upper rear system using the 3 early style Commando rubber isolators. And we've spent a lot of time getting this all mocked up in this direction to allow flex, but we haven't talked about how we're going to control this, I guess you could call it tangential movement, where this entire piece wants to slide either this way or this way. Same with the other mounts. So how we're going to control that is the next issue we'll have to address. I've decided not to use the Commando shim style system, which basically mounts a shoulder sort of onto this piece, which is then shimmed to prevent movement, tiny movement here in and out. The shims, can be tricky to set up, and then once they are set up, you still are going to have 10 or 20 thousandths of movement allowed in this direction, which, on a Commando, my experience is when it's attached to the swing arm, just that movement can, from time to time be a little disconcerting. So I'd rather have no movement here other than up and down. We're also not going to want any rearward movement in this direction, as that would affect the tightness of the chain that's running here. So let me give you a little hint of what I have in mind to address this on a different project that I did a couple of years ago. So let's take a look at that now. Okay, so what we're looking at now is a Lotus 7 car that I made using a Hayabusa 200 horsepower engine. And the thing I want to show you here that I think applies to our isolastic setup is this suspension mounts here, also down here, which are hard to see with the nose on. Here in the back, you'll see it. They are hemispherical joints, often called Heim joints. And what they do is they allow very free movement up and down, but no movement in and out. They're a little bit, unforgiving for street use, but to be honest, I've found that they're really not that bad as long as you have your spring set up correctly in terms of damping and hardness, but you allow plenty firmness, you allow plenty of movement. I don't really notice that the Heims are all that bad, but what I have in mind for our Café Racer is using these Heim joints on the isolastics to limit the left and right or in and out motion. And we'll get into that in the next episode, so stick around.